Okay, so deductive reasoning is the process of reasoning logically from given statements and data. And so there are two laws associated with deductive reasoning. One is the law of detachment, and we'll see the next law in just a minute, the law of syllogism. But for right now, let's just look at the law of detachment. It tells us that when we're given a conditional statement, if the hypothesis is true, then the conclusion is true. Okay, so symbolically, we just want to make sure that we understand what that means. So a conditional statement, remember, starts with a hypothesis, and it implies a conclusion. Therefore, if we're given the hypothesis, meaning that the hypothesis actually is true at this point, we can rationally conclude that the conclusion is also true. The triple dots there just means therefore. It's a symbolic way of writing the word therefore. Okay, so let's look at the example, and that will help us a little bit more to understand the law of detachment. So we've been given this statement. If Mark saves $30, then he can buy a new video game. So we have this conditional statement here. So Mark saves $30 is the hypothesis. He can buy a new video game is the conclusion. And so we've been given that, so that's our P implies Q. Our next piece of given information or given data or statements is that Mark saves $30. Well, comparing that to the hypothesis, we see that the hypothesis actually is true. It's holding at this moment. Mark saves $30. Therefore, we can conclude he can buy a new video game. Okay, so let's look at statement number 2. So we've been given if a quadrilateral is a rhombus, then it is also a parallelogram. So we've also been given the information that quadrilateral ABCD is a rhombus. So based on the fact that our hypothesis states a quadrilateral is a rhombus, and that in this situation we have a quadrilateral that is a rhombus, we can conclude that quadrilateral ABCD is a parallelogram. Simply stating, we've restated the hypothesis, therefore the hypothesis is true in this situation, and therefore the conclusion is true. So we can make that conclusion then. So we have P implies Q, or a quadrilateral is a rhombus implies it's also a parallelogram. We've also been given P, quadrilateral ABCD is a rhombus. Therefore, we can conclude that ABCD is also a parallelogram. Continuing on, we'll see a few examples where we can't make a valid conclusion. So here in problem number 3, we've been given the conditional statement, if you are 18 years old, then you can register to vote. Olivia is not 18 years old. Okay, so you have to recall that the law of detachment has a map saying if P, then Q. We've not been given P. We've been given not P. So because they took the hypothesis and gave us something that wasn't quite the hypothesis, but rather the negation of the hypothesis, we cannot make any logical conclusion at this point because we have not been given any information that tells us what occurs when someone is not 18 years old. Therefore, our conclusion at this point is we can draw no valid conclusion. Number 4 indicates that if the sum of the measures of two angles is 90 degrees, then they are complementary. Measure of angle J equals 58 and measure of angle K equals 32 degrees. Okay, so it doesn't say specifically that measure of angle J summed with the measure of angle K equals 90 degrees. However, we can take these two angles and we can sum them together and determine that the sum of both of these angles is indeed 90 degrees. Therefore, since we have the hypothesis that says the sum of the measures of two angles is 90 degrees, and in this case we've been given two angles and their sum is indeed 90 degrees, we can logically conclude that they are complementary. The last example here identifies the conditional statement: if you plan to attend the prom, then you must purchase a ticket. Sarah purchases a prom ticket. Okay, so we have a hypothesis that states if you plan, you plan to attend prom. Okay, and the conclusion states you must purchase a ticket. So in order to follow the law of detachment, we have to have the hypothesis in the circumstance that we're identifying. We do not have that hypothesis. Instead, we have a statement that somewhat looks like the conclusion, but because we don't know anything about why Sarah purchased a prom ticket or what she plans on doing with that purchased prom ticket, we cannot make a valid conclusion. So basically, because we have not restated the hypothesis in some form, we cannot draw a valid conclusion based on the conclusion of this conditional statement. So our conclusion at this point is we can draw no valid conclusion. So that's the law of detachment. Now let's look at the law of syllogism. The law of syllogism allows us to draw conclusions from two conditional statements in which the conclusion of the first statement is the hypothesis of the second statement. And the symbol map helps us to see that. So the conditional statement P implies Q would be our first conditional statement. And then this condition becomes the hypothesis of the second condition. So Q implies R. Therefore, we can draw the conclusion that P implies R because these two items are identical. The conclusion of the first is identical to the hypothesis of the second. So basically, we are striking out the Q's. Okay? All right, so let's look at an example, and that might make it a little bit more understandable. So number 1 says that we are given, if it is Saturday, then Jake has a baseball tournament. If Jake has a baseball tournament, then he will need to pack his lunch. Okay, so let's take this a little at a time and associate it with our symbol map. So we can see that it is Saturday is the P. Jake has a baseball tournament is Q. Jake has the baseball tournament, as we said, that was Q, and he will need to pack a lunch, ends up being R. So since we do indeed have a Q and a Q that are identical, we can eliminate those two Q's and combine the P with the R. If it is Saturday, then Jake will need to pack a lunch. We basically eliminated that statement, Jake has a baseball tournament, because it was equal in both the first conditional statement as the conclusion and the second conditional statement as the hypothesis. All right, looking at number 7, we have if a number is divisible by 12, then it is divisible by 6. If a number is divisible by 6, then it is divisible by 3. So we need to identify our P's and Q's and R's. Okay, so our P in this case, if a number is divisible by 12. Our Q, it is divisible by 6. When we look at our second conditional statement, we have a number is divisible by 6, which is identical to the conclusion in the first conditional statement. And then we have a new conclusion, it is divisible by 3. So since these statements are identical, this statement here is identical to that statement there, we can eliminate those two statements and just join these two to make our conclusion. If a number is divisible by 12, then it is divisible by 3. So in number 8, we're dealing with the same situation. So we want to find our P's and our Q's and see if there is an R that we can make a conclusion with. So a quadrilateral is a square. That's our P. It is a rectangle is our Q. So if the next statement has something about it being a rectangle, then we have a syllogism. If a quadrilateral is a rectangle, yes, we do indeed. It is a rectangle, and so we have a syllogism, and therefore we can identify this last conclusion as being our R. So now we can eliminate this statement and that statement and combine the two remaining and come to our final conclusion. If a quadrilateral is a square, then it has 4 right angles. Okay, our next one says if it is sunny this weekend, then we will go boating. If it is sunny this weekend, then we will wear shorts. So we need to look at our P's and our Q's. And so we have in the first conditional, it is sunny this weekend. And our conclusion, you will go boating. In our second conditional statement, we restate the hypothesis. It is sunny this weekend, and we have an additional conclusion, you will wear shorts. So in this case, our conclusion of the first is not the hypothesis of the second. So you will go boating needs to be the hypothesis of the second in order for us to apply syllogism. Since we cannot, and we also cannot apply detachment, we have to conclude that there is no logical conclusion that we can draw from this. Even though this may make a lot of sense, we can draw no logical conclusion from blending these two. So all we can say from here is if it's sunny, then we'll go boating and wear shorts. But that doesn't allow us to draw an immediate conclusion from this to this with leaving out the whole going boating portion. Anyway, so our answer to this is no logical conclusion. Number 10 identifies 2 conditional statements. If you shop at Target, then you will use your red Target card. If you do not use your red Target card, then you will not get 5% off. Okay, so we're just going to look at our P's and our Q's. If you, shop at Target is your hypothesis, and your conclusion, you will use your Target red card. Okay, so now when we look at the hypothesis of the next statement, we do not have anything different. Anything the same, because we're not using the exact same conclusion from the first conditional, because it says you do not use your Target red card. Well, since that is different from the conclusion of the first conditional statement, we cannot make a logical conclusion from this because there's no connection between the two. We don't know exactly what's going to happen if you shop at Target and whether or not you're going to get 5% off, because these two pieces do not equal one another. Therefore, the answer to this is no logical conclusion. So this last example is pretty straightforward. The hypothesis, it snows. School will be canceled is the conclusion. And the following one, school is canceled, is the hypothesis. Therefore, we know that the law of syllogism will hold. Students will need to make up a day of school. So we can combine, if it snows, then students will need to make up a day of school. I hope all that makes sense and you can apply these to the other problems you have to work.